Let's have a look at several examples of using the chain rule to differentiate compound functions. We've got a series of 6 compound functions there, and we have to differentiate them. I think the first thing to do is identify what u will be. U is going to be our substitution for the inner function. E to the 5x, well, we know the differential of e to the x to be e to the x, so the inner function in this case is the 5x. We know the differential of cos x from first principles as being negative sine x. So 9x squared is the inner function. We would know the differential of 1 over x, but we don't know the differential of 1 over x squared minus 2x plus 1. So this is the inner function that we're going to be calling u. We know the differential of ln x, but we don't know the differential of ln 2x minus 1. So this will be the inner function. Same argument applies to this function here. We know the differential of sine x to be cos x, but we don't know the differential of the sine of ln x. And again, the same argument applies from column 1 to this column here. Negative cos x will be our substitution of u and our inner function. Okay, so let's write those results down. To use the chain rule, which I'm going to write out here, dy dx is equal to dy du multiplied by du dx. And you can think of this as though the du's cancel. It isn't a fractional expression, but you can at least understand the fact that if we got rid of the du's, we would simply have dy dx equals dy dx. So in order that we can use the chain rule, we need to find both dy du and du dx. And on the left-hand side here, I've got a column of the calculations that we need in stages, so that eventually we end up with dy dx. So let's work down this column here for e to the power 5x and see what we get for dy dx. We've already written u is equal to 5x. The differential of u with respect to x is 5. With the substitution, this y would simply be e to the power u. dy du is e to the power u. If you've not seen or covered that yet, you've just got to accept that result as true. So dy dx is simply the multiplication of this guy with this guy. But I'm not going to write u, I'm going to write our substitution back. So we get 5e to the 5x. And that's the first of our answers. Okay, let's work down column 2, which we've got a trig function. First of all, simply differentiate 9x squared, and we get 18x. Y is equal to cos u. Our substitution being 9x squared, this simplifies to cos u. The differential of cos is negative sine u. Multiplying our du dx by dy dx, we get 18x multiplied by negative sine u. Well, again, sine u, I'm going to put u back as 9x squared. So we get negative sine of 9x squared. Squeezing it in a bit there, and there's our answer. Okay, let's have a look at the third column. First of all, as always, let's differentiate our inner function, and we get 2x minus 2. So now let's write down y in terms of u. This will be u to the minus 1. I've put that as a negative power because it's much easier to differentiate rather than 1 over u, which is what we would have got just by a straight replacement of the expression in x with u. To differentiate this, minus 1 comes down. This will be u to the minus 2. So our result, multiplying line 2 by line 4 again, will be negative 2x minus 2 divided by u squared. So that's the answer to the third of our problems. The fourth of our problems, starting off simply by just differentiating our u, we get 2. The expression of y in terms of u is just ln u. The differential of ln u is 1 over u. Again, if you've not met that before, you'll just have to accept that as true and look back at a tutorial that involves the differential of logs. Right, multiplying line 2 by line 4, we get that dy dx is 2 divided by u, which is 2x minus 1. That's the answer to column 4. The fifth example, we've substituted ln x as u, so the differential of ln x is 1 over x. And y is simply the sine of u, and the differential of sine u with respect to u is cos u. Again, multiplying line 2 by line 4, we get cos u, which is ln x, divided by x. And our last example, we've got to differentiate negative cos x, and the differential of negative cos x is positive sine x. Our y function, by that substitution, is simplified to e to the u, and the differential of e to the u with respect to u is e to the u. Multiplying row 2 by row 4, we get sine x, and I'm going to substitute back away from u, we get e to the minus cos x. And those are your answers.